In today's video lesson, we are covering Introduction to Limits, and at the top, you'll see a warm-up, and it just says, given the statement, write its meaning. So I'd like you to go ahead and copy this down. What we need to do in this first unit is learn how to read and write limits in addition to actually evaluating limits. So this statement says that the limit of f of x, notice how it's written, lim f of x, that reads the limit of f of x, as x approaches a, that is referring to that little part down here that I'm circling in yellow, is equal to L. Now that's true if, and then there's a bigger statement after that. If the limit of f of x as x approaches a negatively, that a to the little negative means we're approaching from the left, and the limit of f of x as x approaches a positively, that little a to the positive implies that we're approaching a from the right, are both equal to L. So the idea here is if we approach from the left and we approach from the right, and both sides are approaching the same value, then that is the limit of the function. So essentially, we need to have agreement on the two sides of whatever number we're approaching. Today, we are going to look at finding limits using tables. You will need a calculator for this. Graphing calculator would be good. Scientific will be good for at least some of it, but graphing calculator is preferred. Let's take a look at our first example here. What we're going to do is we're going to take the function 5x squared, and I'm just going to go ahead and sketch a quick graph of this function. You guys know what this function looks like. This is just the x squared function. It's vertically stretched, a little bit skinnier than we're used to because of the 5. And if I'm approaching 3, if x is approaching 3, I want you to think about the point on this function. The point that should be at would be at 3, 45. So I can see graphically, just by looking at this, since I am familiar with the function, that as x approaches 3 from the left-hand side, I'm going towards that 45. As x approaches 3 from the right-hand side, I'm going towards that 45. So both sides, the y value is approaching 45 as we approach 3 on the x. So that is going to be my limit. Now, unfortunately, it's not usually as easy as just plugging in 3 to get out the value. So how do we use a table to do something like this? Well, what we're going to do is we are going to approach 3 from the left side of 3. So we're going to go to the left of 3, so go to 2. That's a little too far. Get a little closer. So we're going to go to 2.9, and we're going to just plug that into our function to see what we get, and we get 42.05. Then we're going to get a little closer. We're going to go to 2.99 and then even to 2.999. And you're just plugging those into the function 5x squared to get out the corresponding y values. So we get 44.7 and then we get 44.97. So what I'm doing here on the first half of the table is I am having x approach 3 from the left of 3, but very, very, very close to 3. So 2.9, 2.99, 2.999. Now we are going to do the same thing, but we're going to go to the right side of 3. We are going to have x approach 3 from the right-hand side. So we're going to go to the right, 4, let's say, but that's too far. We want to get closer. So we're going to try things that are really close to 3 on the right of it, like 3.1, and then even closer, 3.01, and then even closer, 3.001. Go ahead and plug those in on your calculator. Make sure you get these same values I'm seeing here, 48.05, 45.3, and then 45.03. What does this tell us? Well, as x gets closer and closer to 3, look at these two values that are the closest, my y value is getting closer and closer to 45. So I'm analyzing the behavior of my function using a table because I don't want to make a graph for every single function every time. Let's try another one. Example 2, find each limit below using a table. Verify your work with a graphing calculator. So we're going to set up an XY table. We are going to have x approach 2 from both sides. So let's go to the left of 2, 1.99, 1.999. Let's go to the right of 2, 2.01, 2.001. Go ahead and take a minute to calculate those values. And then go ahead and choose on the Edpuzzle, what is the limit of this function as x approaches 2? And we determined that as x gets closer and closer to 2, the y values are getting closer and closer to 4. So the solution to this should be y equals 4. Now, when I do part B, you're going to create the table, and you are going to notice that you will get the exact same table. You plug in those same x values because x is approaching 2 again, and you will get out the exact same y values. Why is that happening? Well, if you look at your expression in part A, if you took that expression, x squared minus 4, and you factored it to x plus 2 and x minus 2, you would see that you have a common factor, top and bottom. So you are able to actually simplify this to just x plus 2. So since this part B is a simplified version of what we have from part A, we are going to have the same table, which means we are going to have the same limit. Why is that important? Well, we're going to see later on that an algebraic technique is just simplify every time. And if you can do that, then that will help you evaluate this thing. Okay, so these are the examples of looking at finding limits with tables. Let's now go ahead and talk about finding limits graphically. This can be a little challenging. Now, when we find limits graphically, there's kind of 3 different scenarios that all have the same limit here. In each of these 3 graphs, as x gets closer to the x value we're labeling c, the function's getting closer to the y value, which we're labeling as n. The c is on the x-axis for all 3 graphs. So we are having x approach c in all 3 graphs. And in all of them, the function is getting closer to n. However, there's different situations going on at each of these n's. Since the function gets closer to each n, we can say for all 3 of these graphs, the limit of f of x as x approaches c is equal to n. So all 3 graphs have the same limit value. As x approaches c, the limit is n. However, in the first graph, the output at c is n, which is normal, which is what we typically see. But in the second graph, the output at c is somewhere else. It is not n. Here's what I mean. In the first graph, the output at c is n. There's a point there, c comma n. Okay, fine. So the limit is n. That feels intuitive. In the second graph, there is a value at c, but it's not n. The value at c is up here. So at c, there is some point that exists, but it is not the same as the limit value. So if I ask, what is the y value at c? It's up there. But if I ask, what is the limit as x approaches c? It's n. So the limit and the output might be different things. That's important. Now, the third graph is even more different because in this one, f of c doesn't exist at all. F of c does not exist at all in this third graph. If you go to f of c and I ask, what's the output at c? There is no y value there. So there is no output at all for c, and that is also okay, but it does not affect our limit. So our limit can be the output at that value, or the limit could be different from the output, or there could not even be an output, but you can still have the limit being n. So in all of these, the limit is n, even though there might be what I call a distractor point in graph 2, or there might be no output at all like in graph 3. So let's go ahead and see how that helps us do a couple problems here. Starting with example 3, we're going to do this without a graphing calculator. We are going to find the limit of f of x as x approaches 2, and we are given a piecewise function for f of x. So let's just start by graphing this. Go ahead and graph the line 3x minus 2, and then you're just going to exclude it at 2. So put a hole at 2, and then graph this point instead. Take a minute to do that. The way this function is defined, I have the line 3x minus 2, so I graphed that, but it's everywhere except at x is 2. So at the point 2, 4, I went ahead and just put an open hole to show it's undefined. However, at 2, the function wants us to go put a point at 3. So we have a point at 2, 3. So this is like what we had in the second graph above. The function's output at 2 is 3. That does not affect the limit at all. If I want the limit of the function as x approaches 2, then I look on the main part of the function and I say, what is the function doing? The function is going towards 4 as I approach from the left. It's going towards 4 as I approach from the right. So the limit is 4. And again, this is an example of where the output and the limit can be different things. The output is 3, however, the limit is the main behavior of the function, which in this case is 4. Let's try another one. On part B, we have the limit as x approaches 0 of f of x. And again, f of x is a piecewise graph. Go ahead and graph this, and then choose your limit answer in the Edpuzzle. When you are making your graph, we have the function y equals x to the left of 0. So we're going to go to 0, 0, and then go down 1 over 1 kind of backwards there. So that's the increasing line y equals x, but to the left of 0 and including it. And then we have the function y equals 1 to the right of 0. Notice I don't include it, so I'm going to put a hole there and then go ahead and graph that function. Now, this is my piecewise function. We want to find the limit as x approaches 0. So we are going to look first at approaching 0 from the left-hand side. As we get closer and closer to 0 from the left-hand side, so I'm going to the left of 0 and I'm getting closer, 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 closer to 0, the y value I'm going towards appears to be 0. Then I approach it from the right-hand side. When I approach it from the right-hand side, x approaches 0, positive. I go to the right of my x is 0. I get on the function. I get closer, 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 closer to 0. And the y value I'm approaching there is 1. Reread your warm-up. In the warm-up, we said the limit is a number if approaching from the left and approaching from the right are the same. When I look at this problem, approaching from the left, it goes to 0. Approaching from the right, it goes to 1. They are not the same. So the limit does not equal 0. It does not equal 1. It does not exist at all because they don't agree. So we write that the limit of f of x as x approaches 0 does not exist. You will see us write it as DNE for short. All right, one more problem here. We're going to go ahead and do part C, and we are going to do this problem using a table and or algebraically. They want us to use a graph. We're actually going to not use a graph here. We're going to use the table function in your graphing calculator. So what I'd like you to do is go to your graphing calculator and try to make a table with your graphing calculator. If you don't know how to do that, then just make your table by hand. So approach 2 from the left, 1.99, 1.999. Approach 2 from the right, 2.01, 2.001, etc. See if you can figure out what that limit is as a decimal. Another option is see if you can find this limit algebraically. If I plug in 2 right now, I'm going to get 0 over 0, so I don't know what it is. But remember, in the previous example we saw, if we simplified, then we could find the limit that way. So go ahead and try to simplify. You're going to do that by factor by grouping on top. So if you factor out an x squared, you have an x minus 2. And if you factor out a 4, you have another x minus 2. You're going to also factor by grouping on the bottom. So if you factor out an x cubed, you have an x minus 2. And then if you factor out nothing, you have an x minus 2. Make sure you're strong with your factor by grouping. To simplify, what you want to do is pull out the x minus 2 first from the top and the bottom, and then show what that leaves you. On top, it leaves you with x squared plus 4. And on the bottom, it should leave you with x cubed plus 1. You are now able to reduce this, and now that allows you to plug 2 in. Go ahead and put your answer into the Edpuzzle, either the decimal form from the table or the fraction form from the algebra. From the table, I believe the value you would have gotten was 0.889. If you were doing this in fraction form, I believe the value that you got was 8/9. And you'll notice that that is an equivalent decimal and fraction. So those are the same.